Well, hello everyone, and welcome back to Adrian's Digital Basement. Who's up for a little retro archaeology? I picked up these two computers at the recycling, the same place I got that Blender PC from, and I thought it might be interesting to sort of dig into what these computers are. I literally brought them home exactly like this. I haven't opened them up, I haven't turned them on even, I have no idea what's in these. It's a complete mystery. I have to mention that it's still December and myself and other YouTubers are making some videos for DOScember. Essentially, we're focusing on PC type computers that run DOS or thereabouts. There's no real hard and fast rules to what the videos are going to be about, so they'll be a little bit all over the place. But check in the description below for links to the channels of the other participants, and also do a quick search for hashtag DOScember in YouTube, and you'll see probably other channels participating as well. So anyhow, without further ado, let's get right to it. So what I have here are two mystery retro machines. On the left here, this is a leading edge computer, which was a name brand clone, I guess. You could buy this in a store. I don't think I've ever actually seen one of these for sale, but I think I wasn't really paying much attention when leading edge was for sale. But I think they were making XT clones all the way up through 386. I'm not sure they still existed any longer with 486s. I was able to get the matching leading edge keyboard with the leading edge desktop PC here, and it is a nice clicky, probably Alps or something. We'll take a look at this in a second. It feels very nice. And then this machine is what's known as a mini tower. And this would be a case you could just buy, maybe from a computer store or whatnot, and you assemble the machine yourself. Or potentially you went to a store that did that work for you and you bought this computer complete. But it does have a badge on here, it has a K. It has a red Intel Inside sticker, which was the earlier of those stickers, if I recall. I think they became blue later on. So I'm gonna guess this is probably a 486, possibly an early Pentium. It may have an LED display right here that shows the speed. Of course, it's got a complement of disk drives. It does have a CD-ROM inside as well, which sort of lends itself to this being on the multimedia era of PCs, which is Pentium-ish. Since the leading edge here is probably an XT or a 286 at the most, let's start with the older machine, and then we'll get to the newer one. So I gotta say, the leading edge is in pretty good shape, all things considered. Usually when things end up at the recycler, they've been thrown around, stacked on pallets, and can be a bit beat up. This thing is in pretty nice shape. Of course, we have some yellowing on this front panel, although look at this, the 5 1/4 inch disk drive here does not have yellowing. I wonder what this switch is all about. Is that, oh, it locks it. That is interesting. I haven't actually seen that. I'm not really familiar with this particular mechanism either, but seems to be okay. I don't know if the drive actually works. Someone has added a 3.5 inch at some point, probably 1.44. There's a reset button. There's a power switch on the front, which is kind of nice, and a front keyboard connector. Looking at the side of the machine, it's got two metal screws, same on the other side. It is a metal top, so it's in pretty good shape. It's definitely dirty, got some scuffs, a few scratches, but nothing major. And now looking at the back, so this machine, it's mildly interesting. Taking a close look at the badge here, we have a leading edge model DC2011 from Leading Edge Products Incorporated. And, oh, and look at this. Oh no, the original plastic. It's still on there, but it just shredded. So that's too bad. The badge is in good shape underneath there. Next to the metal fan grill, we have a regular IEC power input, and very odd is we have a US style plug. So this would be for plugging in your monitor so you can have it turn on when you turn the computer on. Pretty common for back then. The original IBM PC 5150 had this. Except instead of having a plug, it had a female IEC jack. So this is a male one where you would plug a power cord into, and then there was a female that was for hooking up to your monitor. IBM 5151 monitor, it actually had a power cord that simply had the male connector on it. It looked just like this, but it was on the end of a cord. So if you wanted to plug it into the wall directly, you just need to take a standard power cord and stick it into there, and then the monitor would work. But you could plug that into the back of a regular 5150, 5160, something like that. A lot of other clones had it as well. And Leading Edge decided to do something a little more standard and just put a standard plug here. So you could plug in a power strip and plug in some speakers, monitor, you know, various other things, and it would all turn on, which is kind of neat. The sticker here does say that it's a 3 amp input and a 1 amp output. So it's not a lot of output current, actually. You wouldn't want to plug too much into there, but some speakers and something small along with your monitor would probably be fine. Propping up the computer here reveals there are internal ports. So we have monochrome, color, serial, and parallel. Now there's a sticker, it's kind of hard to read on the camera. We see it's written there, but it's interesting that it's got a monochrome and a color port. These are both 9-pin, and there's a toggle switch right here to go between the two. Weird is that I've seen a toggle switch before to switch, but it would be the same connector that could do both. We'll have to take a look at what's going on inside, but that's a little bit unusual. Moving on, we have some kind of a blank here, and it looks like, oh, it just was stuck on, and it's for an extra port that you could install. We'll see more about the cards when we open it, but right away we can see that there is a modem here with a volume knob, so it has an internal speaker and something with a 15-pin connector here. It looks like a game port connector, but I don't know what the dip switches are all about because game ports are fixed. The base I/O, you don't need dip switches. I'm not quite sure about that. There's a blank there, but this one is offset from the back of the computer, unlike this one. I have a feeling there's no card in this slot, but in this one, there's probably something like a hard drive controller or something, or disk controller or something like that. All right, I have the screwdriver here. Let's pop this open and take a closer look at what's inside of it. Place your bets now in the comment section if you think there's gonna be, a hard drive. Is this just an XT? What's the deal exactly? My guess is it's gonna be an XT class machine, 8088, not even 8086, just 8088. And it's going to have a 3.5-inch hard drive, potentially a hard card or something along those lines. So this will have a hard drive in it, and I'm gonna guess the year this thing is from. It's probably later in the XT era, like you could buy faster machines already. I'm gonna say like 1980, later 80s, like 88. I think one more screw right here, and I'm gonna guess because there was a screw here that the case is gonna go that way. Yep. Let's turn this around and look at it together. So you just pull forward and lift off. Oh yes. Well, let's turn this sideways here. That's what I'm talking about. It does have a hard card. And I was wrong. I thought it only had 3 cards in it. It has all 4 installed. So right off the bat, I can tell that this card in here, this is the hard drive controller. It's either MFM or RLL, and this is a Western Digital card. And I think they sold an entire kit where you could mount this hard drive right with the card. The card has special holes to mount onto this. And this is all held in on the front of the case and on the back. This might have been OEM with this computer, but it looks like the hard card just sticks into the front of these case on these standard slider things. So this would work in any computer theoretically. Now the hard drive, if I tilt the computer up, it's unbranded, at least on the top here. Maybe there's a sticker somewhere else. We'll have to take that card out, take a look. Next up, this is definitely the disk controller. I'm surprised it's not built in the motherboard because other things are, so that's a bit funny. I'm just gonna quickly pop the screws out for the cards so we can just take a quick look. All right, here is card number 1. Now, I'm fascinated. This is cool. I like this a lot. This is a universal floppy drive controller, and what makes this special is it has a ROM BIOS on it so that this probably supports all types of disks. Yeah, see right here, 360, 720, all the way to 1.4. So on an XT class machine, you pop this in and you can support up to 1.44s automatically, even though the BIOS in those machines, like on an original IBM PC 5150, 5160, they don't support high density. But with a card like this, absolutely will. And look, 2 floppy drive ports. In fact, this one says floppy disk drive C and D, and I take it if I flip this down, A and B on the top one. So theoretically, with no hard drive, you could directly drive 4 floppy drives. Now I know Shelby on Tech Tangents, he did a whole video about 4 floppy drives in a PC. But cards like this potentially make it possible. Next up, boring modem. Here it is. Not much to report. AQL has branding there. Oh, it's actually a Prometheus Products modem. I remember that company. They made lots of modems back in the days. I think they made other stuff as well. Did they make video cards, stuff like that? Either way, the date codes on these chips is 1988. So that, if the rest of this computer matches that, I was pretty darn close to my guess of 1988. The next card, I think, is the game controller, and absolutely, it's a Craft game controller card. Craft was, they made a lot of joysticks, so this card is probably really well documented. I'm sure I can figure out exactly what it does, but very soon after these types of cards were available, people would buy sound cards, and the game port was just integrated in, so no one was really buying these types of cards anymore once sound cards became popular. And then let's slide out this hard card and just take a look. There is actually branding on there. Sorry, I'm trying to get the glare not to shine. It's a shiny sticker. Made in Japan. It is a Kyocera hard drive. I'm not sure I even knew that they made hard drives, but there's the heads and cylinders that are bad, and there's nothing written on it. Now, looking at this controller card, I was sure that was a Western Digital card. Let me flip this around, but I guess it's not. OMTI? The mark of better PC and SCSI controllers? Okay. It seems like most MFM hard drives were only designed to last a handful of years. So the fact that this might work, I mean, we haven't turned this machine on, like I said, but this may work. Who knows, right? This whole machine is incredibly clean inside. So I'll be really curious to know if this does work. We will test that. All right, well, here's a shot of the motherboard, and it actually extends all the way to the other side of this case. So it's a pretty large motherboard, but a few things stick out right away. There's a battery on here. It's a NiCad, the type that really leak, and thankfully it has not. So that is gonna be removed immediately from this case. But what's weird is XTs don't have a BIOS generally, or they don't have CMOS settings, that is. There's no way to like store any kind of settings. They use dip switches. So what exactly is the battery for? Is it just a real-time clock battery? Is it storing settings? Yeah, I have to wonder. So I just noticed something. Here's the ROM BIOS chip here, and it is branded Daewoo, which is interesting because just like the Blender PC, that thing was made by Daewoo. We have another machine that's made by Daewoo. But take a look at this. I'm wiping the dust off. There's just a little bit of dust. Intel 8088. That's just as I assumed, that this is an XT class machine. Also, there are date codes on these chips, and pretty much everything is 1985. So I guess I was off by my guess that maybe that card that was added in with 1988 on the chips, like the floppy drive controller, I think, must have been done later. Maybe when they added the high density disk drive, that 3.5 inch looks like a high density drive. Now looking on the motherboard, by the way, see these blue things right here and there, and there's a few over there. Those are tantalum caps, and they go bad and they short. And typically they do it on the 12-volt rail. So before I power this up, I'm just going to do a quick test with the multimeter between the ground and the various colored wires on here, which are the different rails, and we'll see if there's any shorts. If there is, I'm going to have to fix that. Over here on this part, there's some dip switches there, which just kind of coincides with what I was saying about configuration. On the front, we have some connections here that go off to LEDs, I guess. And in fact, the keyboard connector, which is on the front, is connected to a pin header on the motherboard. It's not permanently attached. Over here, we have what looks like the memory. So it probably has 640K. Unfortunately, a lot of it's soldered on there. So if there's any bad RAM, that's going to be a bit more involved of a repair. This power connector does not look like a standard power connector. It is a different form factor, which means that if this power supply is bad, that's going to be a bit harder to fix as well. I'll have to repair the power supply itself. And on this side, you can just see the motherboard peeking through, and take a look. There it is, the Daewoo branding right on the motherboard. It does have a part number, 210-500-4102. Over here, there's a pin header. I wonder what that goes to. It's not populated. There's a jumper there as well. I'm noticing here on the power supply, it has some nice adjustment potentiometers, and they're accessible right through the case. +5, and a +12 voltage adjust. All right, here's the multimeter. I have it in resistance mode, and let's just do some quick checks, see what we see if we see shorts. 18 ohms, that's probably okay. That's definitely not a dead short. We're looking for like 0 or 1 ohm, that kind of thing. That would be a dead short. 93, that's probably fine. Oh, that's NK, that's totally fine. 200 something ohm, that's fine as well. And then there's a purple wire. We'll check that one. Yeah, okay. I'd say everything looks good. I don't see a dead short there. All right, before powering this on, I want to get this NiCad out of here. I'm just going to use my flush cutters, and I'm just going to cut this thing right out of here. Sorry for going handheld. Hopefully that's visible, but there is a little bit of leakage on that side. It's super minor, but that could cause problems nonetheless. There we have one slightly leaky NiCad battery. These need to get recycled. You shouldn't throw these in the trash. They have toxic chemicals in them. And things don't look too terrible right here with that corrosion, but like I said, need to be cleaned up. All right, so there's a VGA monitor here, and I want to hook that up to this. Now, how are you going to do that, you ask? Because this has monochrome and probably CGA output on it. Well, I happen to have this little FPGA converter board thing. It's really not great. I don't like this. It's an older design. It just does a terrible job scaling, but it does support EGA, CGA, monochrome, and it all converts it to VGA. I don't recommend buying one of these. I got it off eBay. It came from Asia. It's an old design. I think there are much better ones of these out now, but I don't have one. I'm gonna first plug this into the monochrome port, and I'm gonna flick that little toggle switch to the down position. And here we go. Well, it sounds like it's working. Hey, there we go. We got a little bit of a picture. And it's really dark. Let's see, I gotta toggle these switches because we got different colors. Let's see, well, we could get rid of these scan lines. And the other thing I hate about this thing, look, it's got 640K, is the picture's shifted. So I gotta, there's some like buttons on here. You can do stuff. Vertical position, let's see here. Yeah, the worst thing about this adapter is when you first turn it on, it's never centered. And then the other thing is it doesn't save any of the settings. So if I power cycle it, the picture is gonna be all messed up again. Anyhow, here we go. Phoenix BIOS, 1984-85. These guys were very early on, and the Tandy 1000 line of computers, which is also one of the relatively early clones, it also used the Phoenix BIOS. So we have a couple obvious errors: no scan code because keyboard's not connected, and disk is bad because the controller's out. I took a look at the motherboard underneath there. I just peered under. There are no pin headers, so this doesn't have a built-in floppy controller. It must have had an original, probably 360K controller, and I definitely need a keyboard to continue working, right? So this is the leading edge keyboard. Notice it also has the plastic on the sticker here. Let's see if I can get this sticker off without carnage. Oh, look at that, peeling it off. Beautiful. Yeah, the sticker underneath, it's pretty nice as well. Anyhow, this is the keyboard for this thing, and it's pretty heavy. I mean, it's solid plastic. It's plastic on both sides, not like a Model F weight by any means, but this is no crap keyboard either. The layout is very similar to the Model F, although clearly it's got stabilized keys because I can push enter up here or down here, anywhere, and it has a very nice feel. Model F is not stabilized. Look at this giant plus key. That is a big, big key, and it is completely stabilized. Clearly, all of these keys are stabilized. That's more than you can say for the Model F. Alt and Control are Model F style, where they are not full width. It's just a single width, but it's a double width key. But it feels stabilized because I can push on the edge here, and it absolutely works perfectly. But yeah, what a nice feel this thing has. And here's the plate on the back of the keyboard, leading edge, model number DC2014. And no date code or anything else on the back here to give away who made this thing. It's kind of cool. The keyboard cable comes out of the side of the keyboard, and if we look at the connector, it's a right angle. And remember, it's on the front of the computer, the connector, and this will keep it from hitting the keyboard, so you can actually push the keyboard right up against the front of the machine. You don't have the wire coming out, and you don't have this cable sticking straight out of the machine. It's pretty nice. Got a pretty long cord. It's a pretty soft cable, although it's a little bit mangled. It could use the trick where you turn it backwards to re-tighten it, because I think everyone's going to be super curious. Let's pop one of these keys off and see what we find underneath. and it's an Alps blue switch. I'm not super familiar with the clicky of this style Alps. I've actually never owned an Alps clicky keyboard before, but those are the switches, I guess. Alps Salmon, Alps Cream of this style, this mount style, were used on Apple IIc, on the Macintosh keyboards like the Mac SE, the ADB ones, the Apple II GS keyboard. I'm sure a ton of other ones. I'm not a total keyboard nerd. I do appreciate a good mechanical board, and pretty nice that this is a mechanical board. Oh look, double shot keys as well. Overall, very nice keyboard. It's noisy, but it feels very nice. I definitely forgot to mention that the speaker sticks through the front of the computer here, so that's good. You have a nice loud sound, and there is a power LED next to the power switch, and of course the reset button like I mentioned. I'm digging this right angle connector because look, you can put the keyboard pretty close. In fact, when the front cover's on, it's probably going to be butted right up against the cover, and yet the keyboard can still be connected. That's neat. The fan in the power supply doesn't sound super great. It's a little grindy, so the bearings in that are probably shot. I didn't get the keyboard error, and I can hit escape to skip the RAM test. There we go, these two drives are seeking, and the computer looks like it's frozen here, but the floppy drive LED is on, so it is trying to boot. Oh, there we go, boot disk failure. Type any key to retry. I need to quickly remove this motherboard so I can treat this little bit of battery leakage. So I think this works a lot like an Amiga 2000, where the entire floppy drive / power supply thing is on a sled of sorts. So I'm taking out what I think are the appropriate screws. That should allow me to just lift that straight out of the computer case. Getting this power supply connector off, proving to be difficult. There we go. I had to prise it off a little bit, and I accidentally, there was a little jumper pin near there, and while I was trying to pry it off, I bent one of the pins, and it came right off. It didn't have a jumper on it, so I don't know what that does, and I probably don't need a jumper on there, so I'm not too concerned. I think these two screws here, plus the 4 that hold the power supply on, are probably what I need to take off. There we go. It's a little fiddly. The power cable to the switch is still connected, so I just need to move this. Wow, it's really heavy, the whole thing. Just set this off to the side here. And there we have the full leading edge motherboard, and that, it looks like a floppy connector. And in fact, there's the jumper that I broke. Maybe setting that jumper enables this floppy controller port, and taking it off disables it, because obviously it's not working right now because it's using that external card with the BIOS on it, and it's running the floppy off of that. And just having a peek at what we have on the motherboard, this is a 6845 CRT-C controller. I'm assuming this whole section here is probably the video controller, and this is probably a ROM that contains the fonts for CGA and monochrome. And there's probably some RAM mixed in here somewhere that is used. Yep, here it is right here. This is RAM. It's probably for the video card. This actually has 64 kilobytes of RAM right here, which is more than a CGA adapter needs. So perhaps this supports like a 320 by 240 16 color mode. We'll know more when we try Planet X3. As I had thought before, this is the system memory. Here is the serial port controller chip. And down here, these chips with stickers on them. They are most likely PAL chips, not GALs, because GALs are reprogrammable. They're probably PALs. And these would be to simplify a lot of the logic circuitry into these chips. This one says CPU, that says MEM, and there's one here by the power connector that says IO. So yeah, that's probably how this motherboard is relatively small. Like this part of the motherboard is probably the main motherboard, and over here, this part. This area over here is probably mostly for like the serial port, floppy controller, stuff like that. Just popping out the motherboard so I can strategically apply a little bit of vinegar right to where the corrosion is. And I'll just use a Q-tip to spread that around. And then I'll give the motherboard a wash under the tap to make sure all the vinegar is washed away. When this computer was turning on, it was trying to boot off of the 5¼ inch 360K drive. I'm just gonna swap this cable around so that it boots off the 3½ inch. It's a little more common to have 3½ inch discs these days, so that'll be better for the future on this machine. On the floppy cable, you have a twist, and the drive you plug in after the twist is the A drive. So I just need to connect this connector here, which has no twist,
to the 5¼ inch drive on the top. And that will make that the B drive. And then this, this 3½ inch drive, it's a little hard to see, but there's actually an adapter. This pin connector is the normal connector on the 3½ inch, but this actually has an edge connector right here, which is nice. That means this was a relatively expensive mounting kit for this drive because it includes a little circuit board. I just need to line this cable up, get this on here, and now that will be the A drive. There we go. Just need to reconnect the power for the top disk drive. I just unplugged that to make some space. I will need to swap this around because this thing here, these dip switches configure the various disk drives. So it says, someone wrote on there, A, B, C, and D. Well, now the A drive, which was set for 360K, is now 1.4. So these first two switches go down, and then the B column, the second two switches need to go up to indicate, there we go, that that is a 360K drive. One thing I forgot to show is that I replaced the two cutoff battery terminals with two pin headers. So if I want to connect a battery up there, I can. And right there is that jumper block that I screwed up. Well, I replaced that too while I was at it. I had the desoldering gun out, so why not fix that? Let's attempt to get it working with this hard card. How cool would that be if it works, right? This is a pretty decent mechanism. This is in very firmly, and I think with the screw in there and it on the front here, this hard drive is well mounted. All right, here we go. Hard drive is spinning up. Ooh, it sounds a bit weird, but it's definitely sounding okay. Like it's had a little bit of head seek action and it is spinning. Let me hit escape. It is trying to boot off the floppy and I don't know if this hard drive is going to work. Oh, it's booting. That's amazing. Would you look at that? This actually booted. Time and date, menu. Oh yeah. Let's just do a quick look at the hard drive here. Check disk. Let's see if the hard drive's working. It certainly sounds good. All right, so not totally working fine, but we're just gonna hit no on that. Now what's interesting is when it scrolls, it flashes. That is very indicative of CGA, not monochrome, CGA. MDA doesn't do that. Also, I'm noticing the font and everything, it all looks very much like CGA, although it's really hard to tell with this FPGA scaler thing. It does such a terrible job. It just all looks terrible on here. So I don't even know what's going on, but I definitely have this in monochrome mode. But I'm just checking right now and it's definitely plugged into the monochrome connector on the back of the computer. So this is gonna be monochrome. I should switch it over to CGA because the fact that there said games, I assume there's some color games on here. All right, actually, that is monochrome. I had it in CGA mode, but I had it plugged into the monochrome connector on the back of the computer. So I can tell the font now looks a lot smoother. So that means I think those two connections are the same. I'm gonna switch it over to the other cable while it's on here. So while this boots up, let me just talk about this. I have a feeling the two DB9s are connected basically together. It's just that the RGB color one has RGB pins going to it and the monochrome has the two of the pins hooked up to intensity and the monochrome drive signal, which are two different pins that are used on CGA. So it seems like it outputs the CGA or monochrome signal on both connectors, but it just, you know, the monochrome monitor expects the video signal on a one certain pin, and on the CGA port, it's wired up to different pins. It's just the adapter that I'm using can handle both ways. That's an interesting way of doing it, and that explains why it was flickering when I was scrolling, because I was actually in CGA mode. It was just we're getting a monochrome image because of the way it was wired up. Before we go any further, I'm just gonna stick this into the computer. This is an XT-IDE card, and it's actually one I had made. This is like a Glitchworks open source one. I just had the PCBs made, and I was able to assemble these because they're relatively expensive, but yet the chips that are on here are super cheap. And sticking this in here means I can take the load off this hard drive because, you know, maybe it's close to death, and I can copy anything that's interesting like games and stuff onto this compact flash card, and then I won't have to worry about this hard drive just giving up the ghost. All right, so the XT-IDE didn't even show up. It's booting off the hard drive directly. That would imply there's probably a conflict with the ROM address space that's on the XT-IDE card. So I just need to fiddle with those switches to get it to show up at this boot screen. Or this particular Phoenix BIOS doesn't support option ROMs. I don't believe that though. I think it's just a conflict. Currently it is set to D800, and that is probably conflicting with that built-in hard drive controller. So I'm just gonna switch this switch here the other way, and that's gonna change it to be D0000, and hopefully that'll do the trick. With that configured that way, we're actually getting a bus conflict between the ROM chip on here and the one on this controller card. But obviously the MFM controller here was a stronger drive signal and just overrode that ROM entirely, maybe. It's trying to boot off of the floppy drive right now. Why isn't it seeing the XT-IDE still? So I've been fiddling around with this XT-IDE for a while now, and I haven't been able to have it work on this machine. I just haven't had any luck. I've tried various compact flash cards. I've even gone ahead and tried a hard drive. This is an old, I don't know, 400 meg hard drive, something like that, which always works on really old computers. And no matter what I do, this thing sees the BIOS, but when it tries to access the IDE device on IO address 300, which is what the ROM is configured for on this, it just doesn't see anything. And I came to a realization, I think there's an IO conflict. That's my hunch at least. That battery that I took off here seems to be probably for a clock. And I think that's the case because when this does boot into DOS, I see weird date and time appear in DOS. It prompts you when it first boots up, and it doesn't just show the original 1980 date or whatever DOS usually shows. It shows weird things. Sometimes it's like 2030, the year's all over the place, which is indicative of a machine without a battery because the clock chip just reinitializes to random garbage until you set it. Anyways, I'm wondering, is the clock on base IO 300? Unfortunately, to change the IO on these cards, you just can set these dip switches here, but the issue is the ROM, and I just burned this directly from the one I downloaded, is hard-coded for 300, and you need to use a little DOS program to alter that. So I'm gonna have to use a different computer than this, and I will do that change and make it something like 310 or 280 or something like that, and hopefully I'll find one that works on this machine. So I was putting the computer back together and I plugged in the floppy controller card after setting it up for the new disk drive configuration, and the computer wouldn't turn on. Well, it turned out that I inserted the EEPROM the wrong way. The worst thing is, when I first installed it, I noticed the notch, and I noticed the notch on this chip, had them the right way, but then one of the pins got bent accidentally. So I took it out, fixed the pin, put it back in, and sure enough, I put it in backwards. And with an EEPROM like this, when you put it in backwards, it kills it. So that is now a dead chip. What is unfortunate is I did not read this EEPROM out before I killed it. So hopefully I can find another EEPROM for a similar card, put it on here, and have it work. Well, I have been working on this for quite a while and I'm basically giving up. I can't get this controller working any longer. I have an EEPROM flashed. I found this EEPROM on -0degrees.net, and it looks like it's for a card that's seemingly identical to this. I mean, the layout of the components are a bit different, but the chip is the same, dip switch is the same, it's just in a different position. Unfortunately, when I take this card and put it in with this BIOS, it does initialize the floppy drives, but the dip switches don't work properly. It doesn't matter what you set them to, doesn't work. And it also detects 4 floppy drives, I think, and it makes the computer just say bad disk. It kind of seeks the disk drives and then just says bad disk, you have to push F1 to continue. The computer does boot, it does read 1.44 meg disks, but the second disk drive always shows up as 720K. Like I said, it doesn't matter what I set these switches to, it just doesn't work. So if you have a card like this and it works, I wouldn't mind if you could grab the EEPROM and I can at least restore this card back to working condition. I am really kicking myself that I didn't copy the ROM first and then I destroyed the ROM by putting it in backward. So what I did is I plugged these floppy drives back into the motherboard connector, and there's a jumper down here by the power connector, and I did find the actual jumper configurations for this computer, but I was actually able to figure that out before I found those. But it does tell you how to disable and enable the floppy drives.
Of course, that means that the disk drives can only be double density. It doesn't support high density anymore. And that's typical of an XT class machine. So this will work as a 720K drive. It won't read high density disks. So it's certainly better than a 360K. You get twice as much space, right? But it's not ideal. I kind of wish I still had that card, but oh well. And then the next issue is this, the XT-IDE. There's nothing wrong with this card. I went as far as to get another computer, get this compact flash card, 128 megabytes here, all set up, working perfectly. I changed the base I/O of the IDE controller here to 340, I think, or 310. I don't remember what it is, but it's not 300 because, yes, sure enough, I found some threads, I think, on VCF talking about this computer and that the real-time clock is at 300. So that's definitely why this wasn't working. But there's more. There are other problems. If I put this in and I turn on the computer, Phoenix BIOS 2.01, if I hit escape, it's going to try to, there it is, XT-IDE, and it's at D000. It tries to initialize the compact flash card, and right away it crashes. Unexpected software interrupt, 0, blah, 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 R to reboot, or any other key to continue. It does not properly detect the C drive because it is having a problem there. And that thread I found on VCF is from 2011. It's really old. Apparently, this is a problem with these later XT-IDE BIOSes, the 2.0, which is what I need to use the card I have. It doesn't work with the really old ones. And unfortunately, this Phoenix BIOS 2.01 is incompatible. The people in the thread said that the later Phoenix BIOS 2 something, 2.3, 2.1 maybe, and also 3.0 on this machine work perfectly with the XT-IDE. Well, I have searched high and low for that BIOS image because I would just install that into this computer and I'd have a working XT-IDE. I can't find it anywhere, nowhere. So if you happen to see that particular file around, or you have one of these computers that has the later than 2.01 in it, please let me know. That would be amazing to send me that file because without an XT-IDE, this computer is seriously limited. And it seems to be an incompatibility there's no other way to solve. So at this point, I can't use this. I can't use the disk controller because I screwed that up. So at this point, all I can do is put back in the original hard card, which is working. And why don't we just poke around on that hard drive a little bit? I'm going to boot this disk here, which has Check It on it, and it will boot into DOS 6.22, and at least we can run a little bit of diagnostics on this computer from this disk. All right, so DOS 6.22, like I said, it works. C drive should be visible, and it is indeed. Oh, that flashing, not great. Oh, there's quite a lot of stuff on here. Let's just poke around the hard drive a little bit. Let's start at the bottom here. I see a diag folder. Now I did manage to find on archive.org the leading edge original floppy disk, DOS 3.3 and also 3.1. Plus I found some other archive files, zip files, that have all the leading edge utilities for the clock and stuff like that. So that's probably what's on this hard drive. I wouldn't be surprised if that's what this diagnose program is here. But let's just run that. Just see if this is a leading edge program. Yeah, a leading edge diagnostic program. So it gives us a bit of a detection there and it looks like everything is correct. Yes, time of day clock. So like I said, it's got a clock. So you can test things out. So F1 for testing the clock, passed. Why don't I test the keyboard? I haven't done this yet. I just want to push every key. Awesome, it works perfectly. All the keys registered without any issue at all. F5 for monitor test. Let's just see exactly what we got. Color display 2. Press the up and down arrow and press the plus key to execute. All right, tested the memory. While testing the graphics, I did a little bit of reading in one of the archives I downloaded that had tools for this thing. And that mentioned that this early computer does have 64K of video RAM, just like I thought, and it supports 640 by 200 at 16 colors. That's a graphics mode that's pretty advanced for a machine from this era, 1985. That is better than the Tandy 1000, which only can do 16 colors and 320 by 240 and not in any kind of high-res mode. I think in high-res, the Tandy does support
some amount of colors, 4 maybe, but it doesn't support more than that. So here's 640 by 200, 2 colors. That's just CGA. 640 by 200, 16 colors. There it is. Look at that. I might have to send a note to David Murray, the 8-bit guy, about Planet X3. Perhaps he already supports this, and if not, maybe he can add support for this particular video mode. Wow. Unfortunately, that might be too slow for it to work at any kind of measurable speed because it didn't seem to support 320 by 200 or 320 by 240 at 16 colors. It's only supporting that 640 by 200. So that might be just too slow for any kind of game. Okay, let's look in the software folder here. All right, well, this is Broderbund's Banner Maker software, Banner Mania. It's running in CGA high resolution mode, so just black and white. It's got an interesting user interface, sort of graphical, and it looks like you can save and create banners. I'm sure this is for dot matrix printers. Let's see, Dick's Big 50 birthday. Here it is, Dick's Big 50. To transparency and of course, print. And you can do it in color as well. That's cool. I'm sure this software is widely available. You said, let's choose printer. Let's see what printers. Oh, it supports a lot of printers. In this directory is a program called Sidekick from Borland. And if I recall, I've already run Sidekick as a terminate and stay resident. You hit Control and Alt, it brings up this menu here, and this gives you some neat little utilities. So you can have a notepad and it overlays whatever program you're running in DOS. You can actually write notes right into it. And I think there's a calculator, F3. So there's a little on-screen calculator there. It had a few DOS utilities. Looks like an ASCII table. Let's hit F6 to look at that, F6. So in DOS, if I wanted to get this E with the 2 dots on top of it, you would use this 137 here. Yep, so you go Alt 0137 on the keyboard, and then there's the E, Alt 0137, and the E pops up. So that's how you get the extended characters in DOS, and if I recall, that still works to this day in Windows. And here's that program called Copyright, and if I recall, this was a program designed for copying copy-protected disks, doing full disk copies, so A to B, or you probably go A to A as well if you want to just save to RAM. Because early PC games and stuff, booters especially, they were copy protected, and I think things like this existed to try to break that. It's made by Quaid Software in Toronto, Ontario. Well, it was back in the day, but look, it says, to keep up with latest in copy protection, new editions of Copyright appear monthly. You can get your latest edition by sending in your original copyright disc and a trade-in fee of $12 or 15 Canadian. On this machine was a copy of GW Basic, and look, it says include support for extended video modes. So I guess this supports that 640 by 200 at 16 colors. Anyhow, there was a recent video from Noel on his channel about basic performance when he was testing TI-99 basic, and it was so slow. So he tested on several computers, and I figured that this is sort of a contemporary machine because it is the same speed as the original IBM PC AT at 4.77 megahertz. And I wanted to see how fast this basic program runs on this machine, just because it's probably exactly the same as what it would run on a real IBM PC as well. And I think that's a pretty contemporary test to 8-bit machines of the time, like Apple II and other 1981 era machines. So I'm going to use my phone to time this. Here we go. Okay, so I was a little slow on the stop. It probably took about 32 seconds to finish this test. And I ran this on my Apple II Plus upstairs, and if I recall, I got 34 seconds on that computer. So basic performance on the original IBM PC was about the same as on the 1977 Apple II. Even though 4.77 megahertz on the 8088 seems a lot faster than 1 megahertz on the 6502, the 6502 doesn't have to worry about multiplexed address and data bus lines like the 8088, and that really slows down the 8088. Okay, I'm firing up Check It here just so we can take a look and see what exactly the hardware is like on this thing. From all my reading, the leading edge Model D, and I think the Model D means Daewoo, because I saw references to a Model M, and it appears that was made by Mitsubishi. And I say that because I found the BIOS files for the Model M, and it had Mitsubishi in the files. But clearly that's not going to be compatible with this Model D, and I guess that's what the D stands for. When I saw the Model M with the Mitsubishi, I was like, okay, I guess D for Daewoo. Anyhow, there it is, 8088 XT class machine. That's pretty much what we knew. Drive C is a 33 megabyte drive. It is showing 16K here, but I know that it does actually have 64K on the motherboard. I saw the memory there. Built-in serial and parallel port at the standard address. Of course, no game port because I took that game port card out. Phoenix BIOS date matches exactly like the chips on the motherboard. It's from mid-1985. Unfortunately, I didn't have room on the disk to copy checkit.ovl, so I can't run the benchmarks. But I can guarantee you that this thing runs at exactly the same speed as the IBM PC. Just 4.77 megahertz, bone stock, no turbo functionality, nothing. Apparently, it was later leading edge machines that supported a turbo mode. I think there was a physical switch on the back, and they could run at a little bit over 7 megahertz or at 477. And I think the really later versions of this machine could only run at the higher speed. I just wanted to take a look. One last thing to look at on the hard drive. Well, it says MS-DOS 3.3, but is this the leading edge version? One way for me to tell if the clock is working is I'm gonna just set a date in there, invalid date. Oh yeah, right. 2020. Let's see if that worked. Okay, so it's stored, maybe, and I'm gonna Control-Alt-Delete, reboot the computer, and we'll see if that date is still stored in there. Without the battery, if I power cycle the machine, it will clearly get lost, but it should survive rebooting like this. If it had no real-time clock, rebooting, it loses the time even rebooting. Yep, there it is, 2/2/2020. So the date was saved. That definitely means that this computer has a real-time clock that is working with DOS. Cool. So I was about to give up on this computer, close it up, and finish up this video, but I went to have a bite to eat for dinner, and I thought about something, came down and tried it. So let me show you what I've done, and then I'll talk about what I actually did. All right, so it's booting up. Yep, SanDisk, and it's actually booting into DOS 6.22. There it is. It's working. It's freaking working. Okay, so how did I get this thing working exactly? Well, here is the original ROM BIOS from this computer. And yes, I have actually dumped this. So if anyone needs a copy of this, I'll put a link in the description. I'll stick this up on archive.org since there doesn't seem to be a copy, although this is 2.01, so it's not particularly useful ROM. So clearly this computer is booting and I have a different ROM in here. But I said earlier in the video that I couldn't find the newer updated ROM for this computer. So what did I do exactly? Well, I went on to -0degrees.net and I started looking at all the other BIOS ROMs from XT class machines. And I noticed that there were several others that had Phoenix BIOSes on them, and the version numbers were similar to the leading edge, like 2.51, which I think is what I downloaded and I put on this computer. The original ROM chip that's in here is actually a 16K ROM. This is a 27128 EEPROM, and that's actually what I ended up burning in here. But the ROM I downloaded, it was only an 8K ROM, while this one actually was 16K. So I'm not exactly sure what the difference is, but I figured they were both Phoenix, and there was a good chance that the motherboards were similar enough that things would work. Now the trick of burning an 8K ROM into a 27128 is you have to put the ROM at the second half of the chip. And that's because when the computer turns on, it starts to execute from the top of the ROM space. That's where the 8088 is looking for its initialization vector. I forgot the exact terminology. If you imagine this 16K ROM, it's made up of two 8K chunks, right? And the 16K ROM took up the whole thing, but the new 8K ROM could either go in the bottom half or the top half. And if you imagine the top half is what's all the way up at the top of memory space, which is where the ROM code starts to execute when you turn on the computer. So I knew that the 8K would need to go into that top half. Otherwise, the computer definitely would not boot because it would try to execute code in that upper half of the chip and there'd be nothing there, it would just be blank. So I put the blank chip in my Data IO EEPROM programmer, loaded the 8K ROM image at starting address 2000 hex, and then I wrote the ROM chip, stuck it in the computer as you see here, and I was pleased that the video initialized and it counted up the memory and then it worked. Incidentally, I found that if I was mapping IDE or the compact flash card to 310 hex, it also wasn't working. I wasn't getting that same error about the interrupt, but it was still not finding the card properly. So I just thought, let me try 320 for poops and giggles.
Sure enough, that worked. It shows the card there and it booted right up. So I'm not sure what exactly, but something is using the address space at 300 and also at 310. So thereabouts, those address ranges are not available on this computer, so you have to put it somewhere else. So 320 worked. So loading up Check-It, let's just take a look at what we see. We can actually do the performance test now because this is running off the compact flash card. The question is, what exactly is different on this BIOS from the other one that makes it 8K versus 16K? So far, I can't figure out anything. Everything appears to be working exactly as it was before. The I/O ports are there, the keyboard is working, it sees the disk drives, it's able to read those disks. So really, I got no idea what the actual difference is. So here's the test that we couldn't run before. CPU speed, 4.77 megahertz, exactly as I had thought. And exactly as I had suspected, the speed is exactly the same as the original PC in the PC XT. Let's check the video speed. I have a feeling this is probably going to be identical as well. Oh, it's a little bit slower actually than the original CGA card. That's interesting. Maybe it's got some additional wait states in the memory or something. So I've gone ahead and reinstalled the hard card so I could copy files off of it onto the compact flash. And it's no longer seeing the IDE or the compact flash card properly. I have a feeling this hard card might be using that I/O space, and now we have a conflict again. So I need to edit the ROM on the XT-IDE and change it to something else yet again. I didn't show this earlier, so I'll show it now. To change the I/O address that the XT-IDE uses, it needs to have an EEPROM on it, like a 2864 or 28256. And then you need to boot off a floppy and run the XT-IDE CFG command. Once you've done that, you can load the EEPROM that's on the card, and we can configure the card now. So I have this set to support 2 IDE controllers. I really don't need that, so I'm just going to change this to 1. And then we go to primary IDE controller, and there is the address. So it's 310 and 318 hex. So we know 320 was working, but then I put the hard card in and it stopped working. So I'm going to go up to 330 for that address, and then 338 for this one. So that's one step above where the hard card is. Now, this is typical where general MIDI is. So if you put a sound card in, it's going to have a problem. So keep that in mind. But I just want to keep it in that area. It shouldn't overlap with any of the serial parallel ports, stuff like that. And then we go to flash EEPROM, and it's already detecting that this is a 2864, which is correct. The address space has to be correct based on what the dip switches are on the card. That is where it is selecting. And you need to have the checksum byte yes. Most computers will not honor or like even see the ROM if you don't have the checksum there. And the flashing process is pretty quick, at least for the 64. And now I have to turn the computer off and back on again. But before I do that, I need to change the ID so that it is now on 330. And you look at documentation for the card on how to configure this, but it's binary counting, so I know that is going to be 330. And I just pop this card back in. The hard card looks like it's in, but it's actually pulled out of the slot. So I'm just going to push that back into the slot. So there we go. Now it's in. Let's see if this works now. Spacebar aborts the memory count on this ROM, and on the old original ROM, it was escape. And look, it's seeing it. So that worked. It was definitely conflicting with what's on the C drive. It's actually booting off the C drive right now, which is actually problematic. DOS 3.3, I think, only supports 32 megabyte partitions, and the compact flash card is 128. So that's too big. So I'm going to reboot, and I'm going to push A at the XT-IDE BIOS to boot off the DOS 622. I wish it had a boot menu, but this is the small ROM that fits in the 8K ROM on the XT-IDE, and it doesn't have a boot menu. The version that has it's a XT large, I think, has an option here for a boot menu. So this is the C drive that's on the hard card, and D should be the compact flash card, and it is. And I'm just copying a couple things over. I see a clock driver, I'm copying the diagnostics, I'm copying that basic stuff that was over there that said it supports the enhanced modes. And I'm just going to use Xcopy to copy these programs onto the compact flash. And before I turn this thing off for good, I'm going to park the C drive. Hard drive parked on 2 heads. It parked the compact flash card. Well, that doesn't do anything, but at least it parked the spinning hard drive. So I put the leading edge Model D back together. The case cleaned up amazingly. I used a little bit of Windex and Magic Eraser. All the things I thought might have been scratches came right off. They were just scuffs. Essentially, other than this yellowing on the case and a little bit on the keyboard, this thing looks absolutely mint condition. For supposedly the first Korean computer imported into the United States in 1985,
This thing is a tank. It's built to last. It's a true survivor. Dumped off at the recycling center to be scrapped when someone clearly took care of this thing because it's hardly even dirty. Pretty amazing stuff. Really well-made computer. I was curious, since I switched out the original BIOS chip with this other one, if this high-resolution graphics mode would work. And yeah, we're in the 640 by 200 by 16 color mode. Obviously, it's working perfectly. And this computer, I gotta say, it's working great. It looks so much better hooked up to a CRT. I gotta say, obviously, this is a Commodore 1084, but this has CGA compatible input. Compared to that scan converter I have, this thing just makes crisp, beautiful picture quality. I know it's not gonna come across in the video footage, but this font that this CGA adapter uses, it's very pleasing. It's different than the standard IBM one. The characters are just a little bit larger, take up a bit more of the space. It just looks really good. I'm very impressed. As for David Murray's Planet X3, it doesn't support the high-resolution graphics mode that this computer does. It has several different, CGA-like modes here. Plantronics 320 by 200, 16 color. That doesn't work. CGA 4 shades of gray. That also doesn't work. If you run that, it just gives a regular color palette. So we're essentially just stuck with the standard CGA kind of ugly colors, which is what it is. But obviously, if you switch over to the 2-color mode, I actually think this high-res mode is a little more pleasing to look at. Yeah, it's monochrome, but at least it doesn't have those garish colors, and you can just see a little bit more definition of what you're looking at. Here's a version of Tetris from Academy Soft 1986. Let's just start out with level 5. And yep, this is, let's see, how does this work? Okay, I can't quite remember. Okay, I keep pushing the wrong buttons. Why is it going so fast? Well, there you have it, the leading edge Model D. I'm gonna end this video here. I didn't even get to that other computer. If you like this video and you're interested in this archaeology thing, put a comment in the description, let me know, and then I'll make a follow-up video with that other computer sitting on the floor back there, and see what that one's all about. This one went way longer than I thought it was gonna go. I thought it was gonna be just a quick open up, poke around, boot it up, see if it worked. Turned out I had to do a little bit more to get this thing working, at least with the XT-IDE. It always happens. I figure it's gonna be a quick video, really easy, and doesn't really work that way. So I hope you enjoyed this video. This is a DOScember video running DOS on an old PC. If you liked it, I'd appreciate a thumbs up, but if you didn't, you know what to do. And of course, hit that subscribe button to subscribe to my channel with the notification icon to be notified when I upload new stuff. Comments and suggestions in the comment section below, and don't forget to check the description for links to other participating channels in DOScember, and also give a search on YouTube for #DOScember, as you'll probably find a ton of other channels participating. So that's gonna be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.